All right, so what exactly is EOF? I get this comment a lot from people, I get this question a lot from people where they're like, Dave, like what exactly is the EOF or the end of file marker? Typically if I'm like showing some command or something, or if I'm running in bash on the terminal, I'm piping one command to another, and I'll say, like, oh, they'll read until the EOF. Well, what exactly is that? If you're learning this stuff, it might be a little confusing. I remember when I was first learning this stuff, it's confusing. And to talk about what EOF is exactly, we kind of have to talk about what it's not. So I promise that's more interesting than it sounds. So yeah, let's jump into it. So to explain the end of file marker, I think the easiest way is to actually jump into some code here. So here we are in a brand new directory. There's nothing in here, it's completely empty. Any code I write here, I'll make available online. I'll put like a link to it in the description, but yeah, let's get started. Let's do a simple example using fread. So we're gonna make fread.c. It's gonna be a very simple C program, not a bash program. We're gonna do a C program here. Very, very simple. Let's go ahead and be good and let's return 0. So here we go. Here's a valid C program. It does absolutely nothing. Literally does nothing, just return success. Let's actually start putting some code into it. So we're gonna use the classic fopen, fread, and fclose. If you've never seen these before, I'm gonna walk you through it because they're actually really, really cool. The first thing we're gonna do is we're gonna make a pointer to a file, all capital file. Notice that my text editor already knows to highlight it because it knows it's a special type. Let's go ahead and make a file pointer. This is a pointer to a file, and we can use fopen, which will return this. So we give it the name of file, let's say file.txt, and then we have to give it the flags we wanna open it with. So in this case, we're just gonna read a file, okay? We're not gonna write to it, it's not a binary file, we're gonna read a text file, and there we go, we successfully opened a file in C. We have to do a little bit of checking here, let's go ahead and be good. If fp is equal to null, so if we're given back the null pointer, then we fail to open this file for some reason. For the sake of this video, I'm not gonna worry about errors too much, okay? I'm gonna show you that we should put some error checking here. I'm gonna say to do, well, I don't like the way that highlighted it. To do, better error checking, LOL. Okay, so if this fails, we'll just return 1 here, and then we'll close out of it. So we don't have any good error checking, but that's not a big deal. I'm gonna ensure that file exists. So let's go ahead and actually do that right now. Let's vim file.txt. And let's just put hello world in that file. So that's it. We have file.txt. Inside it, we have hello world. Hello, new line, world, new line. I can prove that if I pipe it to a hex dump like xxd. 0a is the new line here, 0a is the new line here. We have hello, new line, world, new line. No trickery, just a very, very simple text file. And let's go back to our program. We have fread here. So there is something I should point out. We already used the fopen command. So let's go ahead and figure out where that actually comes from. We're gonna do a man fopen, and we'll see that it comes from the standard IO header. So let's go ahead and pull that include here. Before we even try to compile it, we know we're gonna need that include, so let's go ahead and pull it in there. Go up here, paste that in there. There we go. So now we have a simple program that opens the file. If there's something wrong with the file, we return 1. If it successfully opened the file, we return 0. So if we're down here, file was opened successfully, we should be good and we should close the file. Now technically, because the program exits, it'll close the file script, the operating system will close it for us, but we can be good. Fclose on fp. That's how we close the file. So fp is our file pointer. We just call fclose on it and it should close it. So let's go ahead and verify our work real quick. Let's actually compile it and see if it works. Compile fread.c into fread, and there we go, it works. So let's call fread. Okay, check the exit code, it returned 0, meaning it was successfully able to open file.txt. And of course it was, because that file exists, there's no weird trickery going on with the permissions. Let's add some code to this now to actually read the file, because that's the important part here. All right, so between the close and the opening successfully, this is where we want to read the file. So read the file now. Let's put some spaces here. So I'm gonna walk you through what's gonna happen here because it's gonna be a little bit confusing. But here's what we're gonna do. We're gonna say int c, this will be our character. I know we're storing as int, it's a little bit confusing because we can store other data besides the actual character data, meaning we can store errors here. If you've never written much C, this might be a little bit confusing, but we might get back a character or we might get back an error. So that's why we're using an int, it can hold all this data for us. There's more historical reasons there, I'm kind of glossing over it. But now that we have int c, we can say get c. So notice that all these functions start with f. We have fopen, fclose. We're using get c. And this will get 1 character from the file. So get c takes a pointer to the file, and that's it. That will grab 1 character from the file, so we can print that character. Now we could just do a simple put char here, and that will put the character to the screen. That's exactly what it will do. We could actually make it a little bit fancier. We could do a printf here, and we can format it a little bit better. We can say red character, colon, and then we'll do a %c for character data, and then a new line. So it'll just be formatted a little bit nicer because we'll see what actually is going to happen here. So let's go ahead and do this. And that looks good to me. We are missing error checking here, but I'll get into that in a sec. Let's go ahead and compile this. In fact, now that I'm running through this example, I realize we call it fread. We're actually never going to call the fread function. That's a function. It exists. You can call fread. We're not going to do that. We are calling fgetC to get one character from it. So let's go ahead and update the name of our program to match it. So let's get rid of the compiled version. Let's move fread.c to fgetc.c. A little bit confusing. I just want to name it after the actual function that it is. So here we go. cc fgetc, write that to fgetc. Now we will have a program called fgetc. We run it. It read one character from the file. It read the H. That's amazing. So we have file.txt here. It was able to read the H. There's still more to read, obviously, so we're going to have to put this in a little bit of a loop. All right, now we can do the obvious thing here, right? We can just copy and paste this, and we have our H here, we have our E here, we have our L here. Obviously, that's stupid. We're going to need a loop. We have to figure out exactly how we want to write this loop. So we're going to take the really, really simple way of looping this. This is what I like to do when I'm starting to program something. While true, and then we will just do this forever. Now, we do need a stopping condition here, because what goes in here? Like, obviously, while true isn't right. We don't want to do this forever, but we want to break out at some point. So let's go ahead and figure out when to break out. Let's do a man fgetc, and this will pull up the man page for it. There's a lot of stuff here. So let's do fgetc. And the fgetc function obtains the next input character if present from the stream pointed at by stream, or the next character pushed back on the stream via ungetc. Okay, so there's some weirdness that can happen here. But long story short, let's keep going a little bit, and let's look for return values. Here we go. If successful, these routines return the next requested object from the stream. Character values are an unsigned character converted to an int. If the stream is at end of file, EOF, or a read error occurs, so it's either or, the routine returns EOF. Now this is a symbol. This is a symbolic constant that is given to us. So that is super duper nice. So let's go ahead and we can use that as our way of checking. So we have int c equals fgetc. If c equal EOF in all caps, notice my text editor changed the highlighting. That was pulled in because of the standard IO header. That is a symbol that's defined for us. Actually, I don't know if it's a symbol. I don't know if it's just like a pound defined. I actually don't know how it's done, but that's not really important. C equals EOF, then we know we are done. So EOF reached exiting loop. There we go. Now we can break out of this loop and we can close it here. So let's explain what's going on here. Read one character. Stop here if we are done or an error occurred. Because remember, it said that in the man page that it could be an error that caused this. Is that how you spell occurred? Is that spell? Oh, I guess that is the right way to spell occurred. Okay, it looked like too many C's or too many R's. I wasn't sure. And then if we get down here, we read one character, print it. There we go. Perfect. That's awesome. So let's go ahead, compile this, and see what happens. Use of undeclared identifier true. How fun. Okay, I was doing a little bit of testing earlier on Linux. Now I'm on my Mac, so I think Clang is being a little more of a stickler here. Couple things we can do here. We can include, I think it's standard bool. I think you can pull in standard bool. There might not be a man page for it. Let me test this out and actually see if I'm making this up or if this is real. I think you can include standard bool.h and that will define those, and this should just work. Yeah, let's go with that. Otherwise, you could just say while one, or you could do for semicolon, semicolon, whatever you want to do for an infinite while loop. But there we go. Let's go ahead and run this program again. And there we go. This is awesome. Take a look at what happened. Read the character H, E, L, L, O, and then we read a new line. Perfect. WORLD, and then we read a new line. How perfect. How awesome is that? EOF reached exiting loop. So when we use these abstractions in C, fopen, fgetc, fclose, when they have the F in front of them, we have access to this beautiful thing called EOF, and we can check to see if we were given the EOF marker. Now, if you remember, EOF was just a number, right? It said it returned an int C. So we compare int C against this. Technically speaking, we could just print it out. Instead of saying we read a character here, let's go ahead and move this up here, and let's just say read int, because it is an int, so we can do %d to print it. We're gonna print read int no matter what. Even if it's EOF, we're still gonna print it. So let's go ahead and recompile this and rerun this and see what we get. So here we go. Now we have integer value, so it's a little bit different. H, E, L, L, O, and then 10 for world, that might be a little bit confusing, but hey, if we cat the file.txt, we pipe it into like XXD, take a look at this, 68, 65, 60, 60, 0A. These are hex, this is decimal, so it's a little bit different, but hex 68 would be the same as 104. So echo, what is it? 0x68, I think will print 104. Yeah, so you can see that this is hex, this is decimal, but it's the same thing. These are just the decimal representation of the character, so this is using ASCII. So we have HELLO, and then the new line, world, and then the new line, and look at this. EOF is -1. So if you wanted a very literal answer from this video, EOF is -1. But obviously it's more complex than that. That is an abstraction that was created for these F functions specifically. Let's go a little bit deeper, okay? We're gonna go down a level of abstraction and we're going to open, read, and close the files ourselves using the syscalls directly, not the F variants of the functions. The F functions are very nice. F open, F read, F close. They're super nice. They can handle streaming and stuff like that. You can do all sorts of things with it. We're gonna use the raw syscalls now. So let's get to that layer. So let's vim read.c because that is the name of the syscall we're gonna be using. So the same thing here, just a simple C program that does absolutely nothing and returns success. That's awesome. So what we're gonna do here is slightly different. We're gonna open the file and store the file descriptor. This is a number. So it's very similar to fopen, but instead of returning a file pointer struct thing, it just returns the actual number that the operating system has. Everything else is pretty much the same, but you don't give the flags like this. You actually pass the flags as symbolic constants. So we would use O read only here. If you wanted some more stuff here, you could do like O _ create to create the file. We just need this. We're gonna open it as read only. So let me stop right here and show you what's going on. Let's do a man to open. This will give you the man page for the syscall for open. And you can see, oh, look at this. We're gonna need the file control header. So let's go ahead and grab this. This is useful. But we have this thing called here. We have the const char path, and then we have the O flag. The O flag are the flags to pass to open, basically. So if we go down to O flag, you can see here's a list of the flags. So we have O read only, O write only, read write, search, execute, and there's a whole bunch of other stuff here. Take a look at this. There are a ton of different flags here. I'm not gonna dive into what they all do. We're just gonna do the very simple O read only. Let's go ahead and also pull in the file control header because we're gonna need that. That's awesome. Now to check for an error here, we just simply check if FD is equal to -1. It's a sentinel value, but that's how we know that there was an error. So let's go ahead and return 1 here and just, to do better error checking. Technically we do the error checking. It would just probably be better to give the user something instead of just exiting with a failure like this. And then we're down here, we can just close the FD. And that's it, that's very simple. So this opens the file and then closes the file immediately. Let's go ahead and cc read.c into read. There we go. Oh, we don't have close, interesting. Where's close? Okay, so open is in file control and close is in the Unix standard header. I did not actually know that. That's so funny. I usually just pull in all these headers at once, but I'm glad we're going through it step by step. So let's pull in the Unix standard header here. Let's go ahead, recompile that. That's awesome. Run read, check the error code, and look at that. It exited successfully. That means that we were able to successfully open, that's not right. We were able to successfully open the file.txt. We haven't read anything out of it, but we were able to successfully open it. So let's go ahead and start reading data out of it. In order to do that, we're gonna need the read syscall. So read is a little bit interesting. Oh boy, does it require a whole bunch of fun stuff here. Yeah, so let's grab these just so we have them in our clipboard because we're gonna have to pull those in. And let's go down here to the actual read function. It returns a size t, or sorry, s size t, so it's assigned size t, and it takes a file descriptor to read, the buffer to store the data in, and how much you want to read at a time. So instead of going through the docs, I'll just show you how to do it because it's actually pretty simple. It looks confusing, it looks scary, but it's really not, I promise. We can do this. It's an s size t, so that's a signed size. We'll call it n equals read. So it takes the file descriptor, the buffer, and how much data we want to read. Now remember in our previous example, we only read 1 byte at a time. We're going to do the same thing here. It's not efficient, okay? If you were making a program to read data, don't read 1 byte at a time, but it's good for learning. So we're going to read 1 byte at a time. Let's go up here. Let's put these here, put them all on the same level, sort them, and then let's get rid of the duplicates. There we go. So a couple things here. We haven't declared buff. So let's go ahead and declare buff. We can also pull back open the man page for read, and we can see that as a void star buff, we can just make a character data, which is nice. We're going to store it into an array of characters. So we can just make a buff of size 1. There's nothing in this buffer yet, but when this function runs, it will fill the buffer with the data. Now notice the size is exactly the same. We've made it 1 and we're only reading 1. This is on purpose. This is how we're doing it. So now that we've read the data, we can do pretty much exactly the same thing. We can printf read. Instead of saying 1 byte, we can say %zd bytes. Might be a little bit confusing, but that is how you print a signed SI or assigned size t, or S size t. That's how you print it. And then what we put here is we're just going to put the character data the exact same way we did %c, and then we'll just put a new line. So then we read n bytes, and that is stored in, let's go ahead and grab the character out of it. The character c is equal to buff at spot 0. That's what's going on here. We just grabbed that out of there. So now we can print it like this. There's one last thing we should do. We need to do some error checking here because read can fail. How does read fail? Let's go take a look. Search for return. It's successful. The number of bytes actually read is returned. Upon reading end of file, hey, that's the thing we're talking about in this video, 0 is returned. Otherwise, a -1 is returned and the global variable error number is set to indicate the error. So that's amazing. So we will get a -1 if there's an error or it's done. And we will get a 0 if EOF is reached. This is important. Notice we don't get an EOF constant. We don't get some sort of symbol defined. We get set null values. We get a positive number if that's how many bytes were read, 0 if there was nothing to read, and -1 is returned when there's an error message. So let's go ahead and check for these. So if n equal -1, then we know that there was an error. So then we can just print that. We can do printf error reading from file. Again, better error checking would probably be nice, but this is just for educational purposes. So we have our error there. Else if n equal 0, then printf nothing left to read EOF. Else n greater than 0. That's what that means. If we're in this else branch, then n is greater than 0. N is a positive number. If that's the case, then we can go ahead and do the actual read. And then when we're down here, we just close the file and we're good to go. So let's read the file, and that's good enough. Okay, perfect. So let's go ahead and recompile that and see what happens. Oh, yeah, look at that. I just tried to use printf without actually including it. So if you man printf, it brings up the command printf. That's good. This is a learning opportunity. Man 3 printf. 3 is for the standard C library. So now we can see that you have to include standard io.h in order to get the printf function. Let's go ahead. Let's go up here. Let's go here. Drop that in there. I like to sort it this way. Pause real quick. Shift V to start highlighting lines. I don't have to hold it. I'm holding nothing. And I can move up and down, and I'm in highlighting line mode. I highlight all the lines I want. I type, look in the bottom left of the terminal, :sort, enter, and then it sorts it for me. That's how I'm doing that in case you're curious. But now that we have that, let's go ahead and do that. Go out of here, compile it, run read, and read 1 byte, H. Okay, that's pretty cool. That's awesome. We read 1 byte. We successfully read the H byte from it. But we have the same problem as last time. We're only reading 1 at a time. So we have to put this whole thing in a loop, right? So let's do that. Let's take this whole thing and put it into a while true loop, and then we'll figure out what the condition is for breaking. The nice thing is we already pretty much have the conditions here for breaking. Take a look at this. If we have an error reading the file or reading a byte from the file, break. If there's nothing left to read, break. There you go. And then if you know how I like to program, I would just leave those on their own, and then I can move this out of the else branch. So then we just say while true, we do all this work. If it was -1, then we have an error reading the file. If it was 0, then we have nothing left to read. Otherwise, we get down here and we just read 1 byte from the file. So let's go ahead and rerun this and see what happens. So we recompile it. Oh, same issue. I think I would have learned by now. Shift O to put yourself in insert mode and move the cursor up. Include standard bool.h. There you go. And there we go. Recompile, run read, and hey, that's awesome. Let me clear the screen and rerun that. Look at this. It's the exact same thing. Read 1 byte, HELLO, new line, world, new line, and then nothing left to read. So when it says nothing left to read, what does that mean? We have hit this branch where n equals 0. So technically speaking, if we search for EOF, it only shows up in our output. Think about that. There's no EOF in this code, okay? There's no EOF. EOF wasn't a thing. It wasn't a character we read from the file. It wasn't a signal given by our operating system. It was we tried to read data from a file, and we got 0 bytes left, meaning there's nothing left to read, so we know the file is done. That's what EOF really means. It really means that the file is done. Something has signaled to you the file is done, and how do you know? When you, the program, goes to read that data, and you get 0 back. You were successfully able to read 0 bytes. You could think of it like that. That means you're done. You're done reading. All right, so there's still more to show you though, because you might be a little bit confused. You might be looking at this and think, Dave, wait, but I've seen you use EOF in scripts. Haven't you done something like here? Let me make a script real quick. Script, I don't know, simple here doc. There we go. Let's go ahead and put our bash shebang up here. User bin env bash. We'll save that. chmod +x simple here doc. And I will show you all what I'm talking about. You may have seen code like this, right? Cat EOF hello world, and then EOF down here. Looks very simple. You look at that code, you run simple here doc, and it prints hello world. What actually happens is that it invokes the cat program, which reads from standard in and writes a standard out, and bash recognizes this as a here doc, and bash reads everything from this marker all the way until it sees this marker again down here. So you might be thinking, isn't that what EOF is? Here's the thing. EOF in this case is convention. It's just convention. This could be like hello, LOL, and then you go down here and you type hello, LOL, and it works all the same. It's just convention that we call it that. You could literally put anything you want here. You might even be able to put numbers. I think that works. Yeah, so that works. So we call it EOF. It makes sense, but it's not a real thing. It's just any character there. It's just a flag. You could just put whatever you wanted there, and as long as it's the same, bash knows how to process it. So 3 underscores, totally valid. I would never do that. I would probably use EOF because it makes sense. But yeah, if you're confused and you're like, I think I've seen EOF in bash scripts, yeah, you probably have as a here doc, but it doesn't have to be EOF. It could technically be anything. Now there is another example I want to show, and this is going to be a really cool example because if I run cat on its own, it just hangs, right? Now I can type in HELLO and hit enter, and cat spits it back to me. Cat is reading it from standard in and writing to standard out. It's line buffered because I'm on a terminal. That's why it waited for me to type. I could type, world. Oh, I had a typo. I can hit backspace, 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 LD. My terminal hasn't set any of this to cat. Okay, this is all happening on a line buffered mode, which is super convenient. When I hit enter, then my terminal sends it to the cat program. When I hit Control D, then my terminal sends what it has buffered to cat. And what does it have buffered? Nothing. So cat was able to read 0 bytes, and that's how cat knows that it's done reading the file. So when I press Control D, cat got to read a 0 bytes. The cool thing is we can prove this. We have the tools to prove this. Let's cp read.c into standardin.c. We're going to write basically our own cat program. It's going to read from standard in, it's going to write to standard out. So let's open up standardin.c here. There's a whole bunch of stuff here, obviously. We could change this to dev standardin. This will work. It's totally fine to do it this way, but you don't need to because our program is already given standardin when it executes as file descriptor 0. We already have this file descriptor. In fact, we can get rid of the error checking here. We already have this. Just use the already open standardin FD. Now, technically, it could be closed and we could break this program trying to read from it. Hey, that's a fun thing. But let's go ahead and just take this now and compile it. CC standardin to standardin. So we have a program called standardin. If we run it and let's give it some input, let's echo hello and pipe it into standardin. Look at this. It was able to read HELLO with a new line and then it hit the EOF. There you go. That's awesome. We can do -N with echo to omit the new line, and there we go. It just read echo hello. How amazing is that? We could take standardin and read it in from file.txt, and then we get the exact same data here. That's amazing. We could run standardin and then start giving it input. Are you ready? I could type hello world and hit enter and watch what happens. There you go. Once I hit enter, it sent all that data. In fact, I could even write some more data here. I could say, don't forget to like and subscribe. Because if you made it this far, you should go ahead and subscribe to the channel. We're almost at 95,000 subscribers, and I want to hit 100,000 subscribers. Thank you, everyone who has subscribed. I think it's super cool. So yeah, if you're not already subscribed, go ahead and hit the subscribe button, okay? But watch what happens when I hit enter. Bam, a lot of output, but that's because it's reading. Watch what happens when I hit Control D. Nothing left to read, EOF. Did Control D send the EOF signal? No. Control D, my terminal sent what it had buffered up to our program, and that was nothing. So our program was able to successfully read 0 bytes, and it's how you interpret it as EOF. If you want to say it sent EOF, that's totally fine. But if you want to get really, really pedantic, EOF isn't really a thing. It's just our way of saying that there's no more data left. If you want to get really, really pedantic, nothing is anything with computers, and it's just memory and code instructions. But obviously, at a certain point, abstractions are helpful. So hopefully this is helping to demystify EOF even just a little bit. Oh, in fact, you know what? One last thing. I think we can actually take our script here. What do we call it? Simple here doc. Yeah, we could even swap this out if you wanted to use our own program called standard in. So if you look at the simple here doc like this, and if we run simple here doc, it will just print the hello world because it gets it over standard in. So that's pretty cool. Let's go ahead and change that back just before I forget, because that'll cause issues. All right, and the final thing I want to touch on before I finish this video is I know some people are going to be yelling at me in the comments, and they're going to want me to talk about this. Let me show you some things real quick. I wrote the code like this because it was very easy to follow, where we read one byte at a time, and then we showed how to put it into a loop. You would typically not see code like this. People would merge all of this into one line. So instead of having an infinite while loop, you would have something like this. You would have int c, while c equals f get c fp, and then we close that so it saves the value, and then we say not equal to EOF, and then we can put char c like this. You can do all this in one line. This is totally valid, and if I were writing code, I'd probably write it like this. I just think for the sake of the video, this is a very, very confusing line to break apart, where it's like, oh yeah, we're calling f get c. We're storing the value in C. We have to put that in parentheses. So now we can actually check C after this function has ran against EOF as a marker. It's very confusing if you're just learning, okay? So yeah, if I were to write this code, if I were to have code like this in like production or whatever, this is how I'd write it. But I think for the sake of this example, it makes sense just to sort of leave it as is. The same thing, of course, goes for our syscall, where if we do read.c, you could do all of this in one line. You could say like size t n, just declare it up here, while n equals read, and then you give it the arguments here, is greater than 0. So what you're saying is while it's non-negative or non-zero, so while it's a positive number, meaning we're able to read some data, then we can, put the character that we want to write to the screen, and then when we get down here, we know that n is equal to, then we know that n is less than or equal to 0. That's what we know when we're down here. So we know that it was either done successfully or there was an error. So yeah, same thing. You can totally write code like this. I know I will get comments from people saying you should have written it like that. Listen, man, I'm an educator, okay? I got to write it in such a way that's really, really easy to follow. So hopefully that was easy to follow. And yeah, that's me demystifying EOF. So hopefully that was useful. Hopefully that made sense. And hopefully you guys learned something. Like I said, I'll make all this code available online, so you'll be able to check it out there. And of course, like always, I got to give a shout out to my patrons over at Patreon. Thank you so much for your continued support. Look at this. Look at that. I'm pointing to my screen. Can you guys see it? Look. wait, hold on. There we go. 100 active members. I could have just put that sound effect in. I didn't have to do it in real life. We have 100 members. That's amazing. Can we even put them all on the same screen? We can. We can just barely get them all on the same screen. Let me make sure all your beautiful names are up here. Thank you, all you beautiful people. Thank you, everyone who's been here since the beginning. Thank you, everyone who has just recently signed up. You are all awesome. Thank you so much for the support. Again, if you made it this far, go ahead and hit the subscribe button. We're trying to hit 100,000 subscribers. Got some cool updates coming to the channel. I'll address that in a future video sometime, so I don't want to spoil anything here, but really, really cool stuff has been happening behind the scenes that I'm very excited to talk about in the next coming weeks. There might already be a video out where I talk about, I don't know, I'll just check the pin comment. I try to put my updates there. So there you go. Thank you, everyone. Hopefully you learned something. And yeah, see ya.